This is the short version of the history and roadmap. If you want a more comprehensive explanation, please choose our 30 minutes implementation. It is available on the Blazor Pascal webpage, or else choose the 3 minutes introduction on the same page. What is Free Pascal? It's an open source project of the programming language Pascal. Pascal is the best language that teaches you how to program for all operating systems like Mac, Linux, Windows and the Internet. Let's see the steps already done and our plans for Pascal and especially Lazarus and FPC. To begin with, we are convinced that the Internet will become the absolute creating and communicating factor for our future. ChatGPT or not. The Internet will be, or even is, a horizon for all of us. So we concentrate on the Internet in our future goals. Let's go back. In 1995, Borland announced that the DOS development for Borland, so-called Turbo Pascal, would stop with version 7. Borland came up with a Windows-only product, which later was known as Delphi, and it became the successor of the Turbo Pascal. Believe it or not, this has actually caused the creation of Free Pascal. That was in 1989. Now just at that time, the first contributors joined the project. Michael van Kanuyt started and he later produced a Linux port. Version 1 of FPC was launched in July 2000 and after that the preparations for a first release started. Free Pascal has now arrived at version 3.22. Before Lazarus started, the first trial project, Megiddo, began in what now is already another century, 1998. The Megiddo project was a historic attempt to develop an IDE and integrated development environment. But it did not work out that well. The company crashed. While the project failed, it unfolded a lasting impact. Even more important is the fact that it laid the foundations for the development of Lazarus. Lazarus is an IDE and of course it's open source. Lazarus can be used with all kinds of OSs. It allows execution of one and the same codebase, which is unique. And it can be used to create console and graphical applications, Windows services, daemons, web applications and WebAssembly programs. Lazarus FPC works on the inheritable object principle. It has an object inspector that will support CSS and of course it also supports code completion in the process. It has a cross-platform user interface framework. This is called the Lazarus Component Library, short LCL. It will get a cross-platform graphical user interface framework called Fresnel, including all standard components, which can be used by the Skia open source graphical library. Graphical applications created with the LCL can be ported to another platform through recompiling or cross-compiling. A year after this, Matthias Gärtner joined. That was in September 2000. And with Matthias as a member of the team, the project made significant move forward. Martin Friebe joined the team and started his contributions to Lazarus. Pass2JS was created by Matthias Gärtner and Michael van Kanuyt. Pass2JS is an open source Pascal to JavaScript transpiler. It parses Object Pascal and emits JavaScript. We have 2 extras added to serve our community even more. Visual Studio Code is now supported by Lazarus. Second, Delphi Code can be handled by Lazarus and can be recompiled with the Delphi compiler. 1. WebAssembly for Free Pascal and Pass2JS. WASM is designed as a portable compilation target for programming languages. It enables deployment on the web for client and server application. WebAssembly modules will be able to call into and out of the JavaScript context and access browser functionality. WebAssembly also supports non-web embeddings. The next point, artificial intelligence. TensorFlow is a free and open source software library for machine learning and artificial intelligence. It can be used across a range of tasks, but has a particular focus on training and inference of deep neural networks. It will also be of help in the project for Pascal Learning. The Lazarus Learning Project is a project for Lazarus for beginners and for kids. The Lazarus PDF Kit is an ongoing project for our Lazarus programming. It will gradually be extended with all the needed functions one has in a PDF, so we will finally have a PDF kit. It will be usable on all platforms and free, available for any user. The user interface development in the browser is based on two standards: HTML, the DOM, and CSS. CSS offers a lot of possibilities in terms of user interface customization. Instead of introducing a new format to update the user interface layer of Lazarus, it is a logical choice to reuse a successful and standardized mechanism, CSS. The paradigms of the VCL must be completely thrown overboard, and that means no more obligatory positioning, no more properties like top, left, width and height. Instead, all matters for the UI, user interface, and layout must be delegated to CSS properties. In short, the aim of Project Fresnel is to make a set of controls or widgets which are guided by CSS. These controls obey the following architectural principles. The widgets must be streamable. That means the widgets are descendants of T-component and must use published properties. This requirement means a form file can be made, and the Lazarus IDE can be used to manipulate the widgets. The layout and looks are determined completely by CSS. This means every widget has a property which represents the CSS to be used. Additional properties for manipulation in an object inspector can of course be introduced. Multiple drawing backends must be supported. Since Lazarus is multi-platform, it goes without saying that the various platforms will provide a specialized backend, much as the custom-drawn widget set of the FPGA-based widget set offers today. The widgets will be independent of the LCL. No dependency on the LCL must exist. The widgets must be able to coexist together with an LCL framework. An application must be able to handle LCL forms together with CSS-based forms. In effect, the LCL will provide one of the possible backends for the Fresnel widgets. Ideally, a project made with Fresnel widgets should be able to take an existing CSS framework, such as Bootstrap, Foundation or Tailwind CSS, and apply it to a form. CSS has several means to determine the layout. The work on this has been started. A CSS parser and resolver have been created already. A drawing backend based on the LCL has been started and the first layouter has been written. The mapping between tag names and attributes has been abstracted in an interface. It is up to the widget what tags and attributes it reports to the CSS engine. Project Fresnel is a large project to rejuvenate the user interface possibilities of Pascal. The project has been started already and the first results have been obtained. A proof of concept using the LCL as a backend has been created. The code can be found at Git repository on GitLab.